Hello everyone. So now we're going to talk about how do we pick the pivot. Okay. So one strategy can be like we can pick the first element as pivot. Okay. If the input is random, that's actually work. That is going to work fine. Okay. But if the input is pre-sorted, okay, or in the reverse order, in that case, what will happen? I mean, all the elements will go into one set. Okay, and the idea here is that we said that in the partition phase the runtime is order of n. Okay, now how do we pick the pivot? Depending on that, actually depending on that, picking the pivot is going to determine how many times okay, we are going to divide the array into two part. Okay, for example, let me show you an example. Let's see, our array looks like, the set of the items looks like this. Okay, we have actually here 8 numbers, 1 2 3 4 5 6 7 8 9. So okay, 9 numbers, actually the numbers are from 1 to 9, okay, in random order. So if we pick the median number, okay, if we pick the like median number, so that each time it is going to divide the array into two equal part. So how it is going to look like, let's pick 5 here as a pivot. Okay, so in that case, in the left we'll have like 3 2 1 4, and in the right we are going to have like 9 6 8 7. Okay, so let's again from here, let's pick a median value. For example, like let's pick 2. Okay, so if we pick 2, in that case the 2 division, you can see that the 2 partition is going to look like here, say 3 4, and here it will look like 1. Okay, and here also let's pick 6. So if we pick 6, it will here, sorry, not 6, let's pick 7. Okay, so if we pick 7, here it will be like 6, and here it will have 9 and 8. Okay, now it's sorted. So here again, let's pick just any number, and it will be sorted actually in this phase. And here also pick a number, it will be sorted. Okay, so you can see that our numbers are like that. So 1 2, so in the 1 2 we have 3 4 5 6. All right, pivot is 7 8 9. All right, and what is actually the number of division, how many times actually we are dividing the whole array? So you can see that actually the height of the tree here is 3. Okay, we have total 9 items, but height of the tree here is 3. Okay, so in each iteration we are dividing the array almost actually in equal part. All right, and in each iteration we are running the partition algorithm, and partition algorithm takes order of n. We discussed that before. Okay, now depending on how many times we are doing the partitioning, okay, so that is going to determine the total runtime. All right, now let's say another example with the same set of array. Let's pick pivot 1. Okay, so if we pick pivot 1, in that case actually on our left there is not going to be any value, but on our right we'll have all the item. Okay, so like 9 6 8 3 2 5 4 7. Now pick 2. Okay, so if we pick 2, in that case again we don't have anything in left, we're going to have everything in the right. So 9 6 8 3 5 4 7. Let's pick 3. Okay, 9 6 8 5 4 7, and you can see actually what's going on here. So if we consider that like as a tree, you can see that the height of the tree is going to be actually 8. Okay, so that means the total number of partition, the total number of partition is going to be same as the size of the input. Okay, so this is going to be same as the size of the input. All right. All right, so here each time we're doing the partitioning, which is order of n, and the number of partitioning, the number of times we're doing the division or partitioning is same as n. So the runtime is actually, in this case, the runtime is, the worst case will be n times n. Okay, order of n square. All right, but here in this case, if we can divide the array each time into equal or almost equal parts, here the number of division we are doing, the number of times we are doing the partitioning is actually as best as it can be, as good as log n. Okay, and the total runtime will be order of n log n. So this is our worst case, and this is going to be our best case. All right, so you can see that the runtime of the quicksort algorithm is very much dependent on how we are picking the pivot. Okay, so what is the element we are choosing pivot, and pivot is going to determine the length of the number of the partition. Okay, how many times we are going to do the partition, how many times the total the total number of iteration is going to work in the quicksort algorithm. Okay, so depending on that, okay, so depending on this runtime, this is going to determine the overall runtime of the quicksort algorithm. So in the worst case, it can be order of n square, and in the best case or average case, it can be n log n. Okay, so picking the pivot, if we just pick the random value, okay, so in average case actually it works fine. Okay, if the input is random, we can pick the first element as a pivot. If the input is random, means we are picking just a random value. Okay, so in average case actually it works fine. It's actually in average case it can work fine, and it can actually divide the whole array into same equal length. Okay, but if the input is pre-sorted, like 1 2 3 4, now if we pick the first element as pivot, okay, or if the input is reverse order, like 4 3 2 1, and we are picking the first element as pivot, that means actually all the elements will go into S2 or S1, and that happens consistently throughout the recursive call, and the number of recursive call is going to be same as length of n, input size. So that's n, and the partition has runtime n, which will be in worst case order of n square behavior. Okay, now if we choose the pivot randomly, generally it's safe, random number generation, but random number generation means pick a random number and then pick the pivot. It can be also expensive. Okay, so random number generation is another expensive algorithm. Okay, so random number generation means actually if we have like n input, okay, if you have n input, we can actually generate a random number from 1 to n. All right, and we can pick the a r as a pivot element. But how do we generate the random number from 1 to n? That's actually another algorithm, and also it can be expensive. Okay, so another strategy to pick a pivot can be like we can pick the median of the array. Okay, so if we partition array, partitioning always cuts the array into roughly half. Okay, so if the partitioning can cut the array into roughly half, we know that this is going to give us the best case scenario, and the optimal quicksort is going to give us the runtime in order of n log n. Okay, now again the question is how we can find the median. Okay, finding the median means actually sort the array, find the middle two value. So that is another algorithm. Okay, and finding median already required to sort the array. Okay, so I mean, finding the exact median by sorting the array, that's actually another expensive algorithm. So what the strategy we can maintain here? So what actually we can do, we are going to use the median of 3. So median of 3, what is going to be the median of 3? Let's see, we have an array here like that, and they are randomly ordered. Okay, so we are going to take this value, which is a left. We're going to take this value, which is a right, the rightmost element. So this is the leftmost element, this is the rightmost element, and we're going to take the center element. Okay, like any number center. So you can see that the center will be left plus right. Okay, divide by 2. Okay, and you can use the floor function or ceiling function. So this is the element a center. All right, so I mean, that doesn't guarantee that the a center value is going to be the median value, but actually what we can do, we can swap this element if necessary, so that a left is the smallest item, a right is the largest item, and a center is the median of 3. Then we are going to pick a center as pivot. Okay. So what we are going to do, like, let's see, this value is 23. This value is 2, and this value is roughly 12, and this value is what can be it? 100. Okay. So what we want to actually reorganize this value in the same array, so that a left is the smallest item, a right is the largest item, and a center is going to be the median of these 3 items. Okay, so according to that, we can do some swapping. For example, if a center is less than a low, means actually here a left. Okay, we're using different name here. So low means left. Okay, high means right, and center means center. Okay, so if a center is less than low, we are going to do swap between these two value. Okay, so if a high is less than a low, we're going to do the swapping. Here you can see that a high is less than a low, so we're going to do the swapping. Like here, we are going to bring 12 here, we're going to bring 23 here. Okay, now if a high is less than a center, we're going to again do the swapping. Okay, so 23 is less than center, so again we're going to do the swapping, 2300. So we're going to do the swapping according to the necessity, means what we want to keep this 3 value like this. This is going to be the smallest of these 3, this is going to be the highest of these 3, and the center is going to be the median of these 3. Okay, so you can see that here now this is the lowest, this is the highest, and this is the actually the middle of these 3. Okay, then we are going to pick a center as the pivot. So this is just a bunch of step, you can see that, and the runtime of picking pivot element, you can see that it's just order of 1. Okay, constant runtime. All right, so constant runtime, just we are going to just check this item. All right, and based on that, we're going to arrange them, we're going to do some swapping, so that we can reorganize the item in the array like this. Okay, and then we are going to pick this item a center as pivot. All right, so this is the order of 1 algorithm. All right, so this is just one strategy by which we can I mean, it can tell us, like, almost it can give us the center item, means it can give us a random value that can roughly divide the whole array into equal to partition. Okay, but obviously it is not guarantee, it is not giving us guarantee that it is going to divide the whole array into equal to partition, but we're not going to here it will actually make sure that we are not going to pick the lowest item in the array, or we are not going to pick the highest item from the array. Okay, it will be some item between the lowest and highest. All right, so that's why it's just one of the strategy. Okay, so analysis, you can see that in the analysis, you can see that the pivot selection is constant, order of 1. Partitioning, linear time, we talked about that, and running time of the 2 recursive call. Okay, so based on the how many times the recursive call is going to work depends on the number of time we are doing the division. Okay, and that depends on how we are choosing the pivot, and in best case it can be n log n. Okay, so in best case the number of times we are going to do the division is in best case it can be log n, but in worst case it can be n. So in worst case the runtime of quicksort is order of n square, and in best case or average case, okay, it can be n log n. All right, so that's actually all about our quicksort discussion, and hope you understood the concept very well. Thank you.